So, you're probably thinking, wait, the sun vanishing? For 6 minutes? In 2026? Well, let me break it down for you. This isn't some sci-fi movie plot or a conspiracy theory cooked up by a group of overly dramatic astronomers. It's actually a real astronomical event that's been predicted and studied for years. Imagine this: one day in the year 2026, the sun, our life-giving star, the reason we have daylight, and the source of all our energy, just disappears. Not for a second, not for an hour, but for 6 whole minutes. That's longer than most people spend on their morning coffee, and it's going to be a big deal. Now, before you start panicking or booking a flight to the moon, let me clarify. This isn't the sun dying or anything like that. It's not an apocalypse scenario where the end of the world is imminent. Instead, what we're talking about is something called a solar eclipse, but with a twist. A total solar eclipse occurs when the moon passes directly between the Earth and the sun, blocking out the sun's light for a brief period. However, this particular event in 2026 isn't just any ordinary eclipse. It's going to be one of the most significant ones in recent history, and it's going to be visible from a vast portion of the globe. But here's where things get interesting. The sun vanishing for 6 minutes sounds like something out of a fantasy novel or a superhero movie. In reality, this event is going to be so dramatic that it will feel like the sky has been ripped open. The sun will disappear behind the moon, plunging the world into darkness for an extended period. This isn't just about losing light. It's about experiencing a moment in time where the very fabric of our daily lives comes to a standstill. Think about how you'd react if the sun suddenly vanished from the sky. Your shadow would vanish, your plants would stop growing, and even your mood might take a hit. This event is going to be more than just an astronomical curiosity. It's going to be a global spectacle that people will talk about for years. Scientists are already preparing for this moment, and they're excited to study the effects of such a prolonged darkness on our planet. It's also going to be a chance for people around the world to come together, look up at the sky, and witness something truly extraordinary. Whether you're an amateur astronomer or just someone who loves the night sky, this is going to be one event you don't want to miss. So, as we dive deeper into what's happening in 2026, remember that this isn't just about the sun vanishing. It's about understanding the mechanics of our solar system, the power of celestial bodies, and how they influence life on Earth. It's also a reminder of how amazing and unpredictable the universe can be. And who knows, maybe this event will inspire a new generation of scientists, astronomers, and space enthusiasts to look up at the sky and wonder about the mysteries that lie beyond. Alright, let's dive into the cosmic chaos that could make our favorite star seem like it's taking a break for 6 minutes in 2026. You might be thinking, wait, the sun? It's always there. But hold on, our fiery neighbor isn't as predictable as you'd think. The sun is a giant ball of plasma, and inside that glowing sphere, nuclear fusion is happening at an epic scale. Every second, millions of tons of hydrogen are being converted into helium, releasing unimaginable amounts of energy. However, this process isn't perfectly smooth. It's more like a cosmic roller coaster with some unexpected dips. One of the main culprits behind these temporary dimming events is solar flares. These are massive eruptions on the sun's surface that release an enormous amount of radiation and charged particles into space. Imagine if you could somehow throw a giant fireball out of your hand, only this fireball is millions of times more powerful. Solar flares can be so intense that they can disrupt satellite communications, cause power grid failures, and even make auroras visible in places where they're not usually seen. But here's the kicker. These flares are often accompanied by something even more dramatic. Enter coronal mass ejections, CMEs, which are like solar sneezes, massive clouds of plasma and magnetic fields that blast off the sun at incredible speeds. These CMEs can carry billions of tons of material into space, traveling at hundreds of thousands of kilometers per hour. When a CME hits Earth's magnetosphere, it can cause geomagnetic storms, which are like solar-induced weather events. These storms can lead to beautiful auroras, but also pose risks to our technology and infrastructure. Now, you might be wondering how these flares and CMEs could make the sun vanish for 6 minutes. Well, here's where things get a bit more interesting. The sun isn't just a static ball of fire. It has an intricate magnetic field that can become twisted and tangled over time. When this magnetic energy is released in a sudden burst, it can lead to solar flares or CMEs. These events can temporarily dim the sun's brightness because they release so much energy in such a short period that it can overwhelm our instruments and make the sun appear fainter for a brief moment. Think of it like turning up the volume on your speakers too high. Everything else gets drowned out. But wait, there's more to the story. The sun also experiences something called solar minimums and maximums, which are periods of low or high solar activity, respectively. During solar minimums, the number of sunspots decreases, and the overall activity on the sun slows down. However, even during these quieter times, the sun can still produce flares and CMEs that might cause temporary dimming. On the flip side, during solar maximums, the sun is more active, and the chances of experiencing a significant event like this increase. So, if you're wondering why the sun might vanish for 6 minutes in 2026, it's all about these dynamic processes happening on its surface. Alright, let's dive into the wild world of solar activity. The sun isn't just a glowing ball in the sky. It's a giant, churning plasma furnace with magnetic fields so strong they could make your compass spin like it's on a roller coaster. These magnetic fields are like invisible ropes that twist and tangle inside the sun, creating what scientists call sunspots. Think of them as dark patches on the sun's surface, but don't let their appearance fool you. They're actually areas where the magnetic field is so intense that it blocks some of the heat from escaping. Now, imagine if those magnetic fields suddenly snap like rubber bands. This is called a solar flare. These flares are like cosmic fireworks, releasing energy equivalent to millions of hydrogen bombs in a matter of minutes. But don't worry, they're not aimed at Earth. Most of them blast into space, but some can send charged particles our way. When these particles reach Earth, they interact with our planet's magnetic field, creating auroras that light up the skies in places like Alaska and Antarctica. It's like the sun is throwing a party, and we get to watch from afar. But there's more to solar activity than just flares. The sun also has something called coronal mass ejections, CMEs, which are massive eruptions of plasma and magnetic field that can travel at millions of miles per hour. These CMEs can disrupt satellites, mess up power grids, and even cause blackouts on Earth. In 1989, a powerful CME knocked out the entire power grid in Quebec, leaving millions without electricity for hours. So while it's cool to see auroras, you might want to keep your lights on during solar storms. Solar activity isn't just about flashy eruptions. It also plays a role in our climate and space weather. The sun's magnetic field changes over time, following an 11-year cycle called the solar cycle. During the peak of this cycle, there are more sunspots, flares, and CMEs than usual. This can affect everything from GPS signals to satellite communications. Scientists study these cycles closely because understanding them helps us predict space weather and protect our technology. So next time you see a beautiful aurora or hear about a solar storm, remember that it's all part of the sun's dynamic dance with its magnetic fields and plasma. It's like watching a cosmic ballet where every move has consequences for our planet. And while we can't stop the sun from doing its thing, we can learn to predict and prepare for its effects. Because even though the sun is 93 million miles away, it still has a way of making us feel its power. Alright, so you're standing there, probably with a coffee in one hand and a sense of awe in the other, as the sun starts to disappear. It's not like it just vanishes into thin air. No, it's more like it's being swallowed by something cosmic. The sun will slowly dim, its light fading like a sunset that never ends. But here's the kicker. This isn't just a pretty sight. It's actually a scientific phenomenon with some serious consequences. As the sun begins to vanish, Earth's atmosphere starts to play tricks on you. You might notice the sky turning an eerie shade of blue or even purple, like it's trying to mimic the twilight hours. This is because the sun's light is being scattered differently as its brightness decreases. It's kind of like when you turn off a bright lamp in a room and everything goes dark, except this time it's happening on a planetary scale. Now, let's talk about technology. You might think that the sun disappearing for 6 minutes would be a big deal for solar panels, but here's the thing. Most of Earth's power grid isn't entirely reliant on sunlight. However, some satellites and communication systems could experience glitches because they rely on solar energy to function properly. Imagine your favorite streaming service cutting out mid-episode, except this time, it's not just a buffering issue, it's a cosmic one. But wait, there's more. The Earth's magnetic field might also get a little wobbly during this period. This is because the sun's activity affects the ionosphere, which in turn influences how radio waves travel through the atmosphere. So if you're trying to tune into your favorite radio station or even use GPS navigation, you might notice some weird signal issues. It's like the Earth is giving a little wink and then a blink during this 6-minute blackout. And let's not forget about the animals. Birds might get confused because their internal clocks are tied to daylight. You could see them flying around aimlessly or even trying to roost early, thinking it's nighttime. It's like nature is throwing a party without an invite and everyone's getting mixed up in the chaos. Alright, let's talk about why this 6-minute disappearance of the sun in 2026 isn't just a flashy spectacle. It's actually a cosmic goldmine for scientists. You see, when the sun vanishes, It gives astronomers a rare chance to study what's happening behind its veil, like a solar eclipse but with more drama and less sunglasses. This event could help us understand the intricate dance of magnetic fields within our star, which are responsible for everything from sunspots to solar flares. Imagine if you had a super powerful flashlight that suddenly turned off for 6 minutes. What would you do? Well, scientists will be doing something similar but with more telescopes and less caffeine. They'll use this moment of darkness to observe the sun's corona, which is usually hidden by its bright surface. This corona is like the sun's halo, and studying it could reveal secrets about how energy travels from the sun's core to its outer layers. But wait, there's more. This event isn't just about looking at the sun. It's also a test run for predicting space weather. You know those solar storms that can disrupt satellites, power grids, and even your GPS? These storms are powered by the same magnetic activity we'll be studying in 2026. By understanding how the sun behaves during this brief blackout, scientists can improve their models and give us better warnings when these storms hit Earth. And let's not forget about the Sun-Earth connection. The sun isn't just a distant star. It's our closest neighbor and has a profound impact on our planet. From regulating climate patterns to influencing animal behavior, the sun is everywhere. This event could help scientists refine their understanding of how solar activity affects Earth's atmosphere and magnetic field, which in turn can affect everything from satellite communications to auroras. So, while it might seem like a short 6 minutes, this moment of darkness could lead to breakthroughs that change how we view our star and ourselves. It's like the universe is giving us a peek behind the curtain, and we're all invited to watch. Who knows? Maybe by 2026, we'll have a better idea of what happens when the sun takes a break, because even stars need a little downtime.